Hi everyone, welcome to the Autonomous Vehicles Hope or Hype panel. My name is Yinnon Dolev. I lead the innovation activities of Sompo Tel Aviv. And with me, there's an awesome panel of people from France, Japan, Israel, startups, and corporations. And we're here to talk about autonomous vehicles. Let's get started with introductions of the panel speakers. So please go ahead, take a minute to introduce yourself. Amit, please.
Hi, everyone. Very happy to be here. Happy and honored. My name is Amit Rozenzweig. I'm the CEO and founder of Ottopia. Ottopia specializes in teleoperation, which is the product and technology to safely and remotely control vehicles from far away. That technology enables the real deployment of autonomous vehicles, both on public roads like self-driving cars, and also ports, airports, mines, logistics centers, and even agriculture to enable autonomy to happen in the real world. Thank you.
Awesome, awesome. Thank you very much. Professor Kato, please go ahead.
Yeah, thanks for introduction. My name is Shinpei Kato. I'm a founder and CTO of Tier 4. So we are a Japan-based app developing open source software for self-driving vehicles. We actually founded an open source community, which is called Ottopia Foundation 2 years ago, where we more than 50 companies work together to develop open source software, which is called Ottoware. And Tier 4 is using Ottoware to provide a full stack solution and integration for our customers.
Fantastic. Thank you very much. Frederic, go ahead.
Yeah, good morning. Thanks for inviting me. So my name is Frederic Merceron. I'm working for Dassault System. We're a company who are developing the 3D experience platform, which is a cloud solution that helping our customer to develop, simulate, validate, and produce some innovation. In that company, I'm especially in charge of the industry, transportation and mobility, and we're working for 30 years with a lot of OEM. And since many years now, with a lot of startups which are developing also some new concept, and especially in the autonomous capability. Nice to be here.
Thank you very much. And as I mentioned, my name is Yinnon. I'm the head of Sompo's digital lab in Tel Aviv. Sompo is one of Japan's largest insurance company that operates an insurance company in more than 30 countries. Specifically about innovation, the Tel Aviv lab is part of an organization that also includes Silicon Valley in Tokyo. And together, we're working to identify cool and innovative technologies we can take to market as new services for the well-being and safety of our customers. And the team in Tel Aviv includes 7 people. We create those partnerships, and we also make capital investments. I'm happy to host, welcome everyone. And my first question is related to COVID-19. You can't ignore it nowadays. So in your view, how has COVID-19 influenced the autonomous vehicles industry? Please, take it away.
So we're working with a lot of companies who are developing autonomous capability, but since a few months, we see that there is a repurpose of the autonomous capability, not only for itself, but for really a purpose. And for our consumer and our customer, we see that now people are thinking more, and realizing how this can be used in my real life, and under the specific constraints, like for moving all people to the hospital, deliveries, special services to the persons, and people are realizing that, and that really us to translate to a lot of companies which are really developing complete experience, complete services that include autonomous mobility, but not only that, and for really a purpose, making more and more, I would say, customized, localized services, which is based on really small and intelligent vehicle for a lot of different purposes. So a lot of new projects, a lot of creativity, a lot of innovation, but really close to the people.
So sparking new innovation and creativity. Nice. Who else? Professor Kato?
Yeah, I really wish today we could provide autonomous vehicle services to support delivering or transportation, but technology is not there yet. So right this moment, I believe what we're supposed to do is probably we focus on research and development of technology so that we can make it ready as soon as possible. It might be after COVID-19, but once this pandemic is gone, then we really want to be ready to start providing services. So we are working hard now.
Very well. Thank you very much. Great.
Yes. From my perspective, I see a few changes or a few impacts. Number one, which is very practical, many companies are doing public road testing of autonomous vehicles, and they usually have two people sitting in the front. And because of the minimum two meter distance, they can't have two people in the same car. So they're effectively can't do any public road testing of autonomous vehicles, which is taking it a bit by delay. That's one. Number two, very strong trend of robot deliveries as part of a bigger trend of last mile delivery, contactless delivery. People say that this will continue, that people will use more and more delivery to their homes instead of going out to the supermarket. And the robot delivery, which is also autonomous, is a big part of that. So that's number two. And number three, I think we are starting to see a consolidation, especially in the robotaxis domain, which is maybe one of the biggest problems to solve alongside the trucks. So I imagine we would have fewer and fewer companies able to continue to work on robotaxis. Some of them will be acquired, some of them will be shut down because of the overall macro trend in the economy, which is it's more difficult to raise money, etc. So that's another thing that it was already difficult before, and now it's a bit more difficult because of the COVID-19.
Excellent. So for our audience, the way it works is that each and every one of us prepared a list of questions for the rest to discuss. Please feel free to argue and fight or disagree. So next question is about mobility as a service. Amit, please.
So my question to the panelists here is the following. Mobility as a service, one of the, again, holy grails of having humans being able to move from place to place via an autonomous vessel, be it a shuttle or a robotaxi. What do you think is the missing product or products to enable mobility as a service? Maybe things that are often overlooked, that people don't really consider an important piece of the puzzle when imagining mobility as a service level 4 world.
Yeah, so what we see is that we have seen in the aerospace, we're working with a lot of aerospace companies for many years, where they are doing virtual certification and homologation. And what we see here, which is going a little bit slowly, and we need to accelerate, is the capability to homologate, certify, and validate a specific services for a city, a country, or a region. And we see that we are still missing on both sides the virtual capability to do that, because it's to be able to simulate the open world, which is by definition infinite, but also some regulation. We see some regulation coming by country in France, Germany, Japan, North America, but not yet consolidation of the regulation that will enable some small company not to do infinite regulation, but at least to have a baseline where it's okay, no, my vehicle is certified for the specific purpose, for the specific services, and I can deploy it and sell it in that country, in that region. So, and this is where we're trying to work with several customers. And I was mentioning aerospace because they are doing that since many years. They don't crash an airplane. They make it live already, and we have to do it the same for autonomous capability.
Thank you. Professor Kato, your thought?
Yeah, that's an interesting question, right? That all of us actually have been thinking for a long time. From technology perspective, think thousands of pieces still missing. Like even AI is not sufficient enough. And as Frederic mentioned, certification is still far away from production. And probably this is Amit expertise of the communication, the mobile communication. In order to monitor autonomous vehicles from remote center, we need 5G, more robust networks. All of them actually still missing. However, having said that, if you can properly define operational design domain, which is kind of the definition of a set of regulations that allow autonomous vehicles to operate in real world. If you have some constraints on this operational design domain, then I still believe that we can provide very limited functionality, though I think we can in the near future, start real services, even though there are missing pieces, if they can be covered by operational design domain. That's my idea.
Thank you very much. From our perspective, one thing that people don't typically think about when it comes to mobility as a service in autonomous vehicles is insurance. And the insurance models are going to change. In theory, the insurance industry has an incentive to quickly adopt autonomous vehicles because it's going to be safer. Cars are going to be driven in a safer way without human errors. That's in fact, there's some challenges and barriers way to get there. Of course, you mentioned the regulatory aspect, but also how do you determine policy? How do you underwrite a policy? Typically, it's not based on historic information. Well, we don't have historic information here. And so this is another involving way. AI is definitely play a big role here. For example, we actually launched mobility as a services in Japan with some partners, particularly around peer-to-peer and other types of models. And I think the jury is still out with regards to how will the insurance industry benefit or grow into autonomous vehicles. But it's definitely the future. This is something that is not going to go anytime soon. So with that, talk about some hardcore engineering of autonomous vehicles. Frederic, your topic.
Yes, sure. So this is a question that I like to ask to our customer, and especially the engineer who are working really on developing the solution is what would you miss, in terms of working together, in terms of software capabilities to help you to develop and simulate your concept, really in terms of tools, productivity tools, simulation tools, it could be anything, or value network tools. What really do you need to go faster and to be more efficient?
Our company is working on a automotive grade teleoperation product, which means the capability to remote monitor and even assist autonomous vehicles from various types of vehicles in various types of operational design domains, from forklifts to trucks, robotaxis, and many types of robots that are moving on the ground, from small to large. Now, we've done thousands and thousands of rides and kilometers of testing with LTE and LTE Advanced, and we're doing 5G tests of our technology and how our unique machine learning based model can predict various network conditions. That's our unique IP. Now, we have not been able to find a cost-effective way to do most of it in simulation. The existing simulators that are today for LTE networks and LTE-A networks are very, very expensive. And in contrary to what you can find in the world of AV, where in the world of AVs you have 3D modeling, 3D rendering engines, some of them open source, where you can simulate, although it's not aerospace grade, but it's still very important capability that exists in the world of AVs thanks to advancements in computer graphics. In cellular networks, we were not able to still find the parallel simulator that would be enough for our requirements in a reasonable price. Not something that only maybe the military has or something that's extremely expensive. So to your question, if I had a better simulator, I would save a lot of money on public road tests, and it would make our advancement even faster.
Actually, this is something that may also help what I mentioned earlier about insurance. The more simulations we have, probably the closer it gets us to the real thing in the absence of mass adoption and regulation.
This cannot replace the real world tests, whether we're talking about the autonomy technology or the teleoperation technology. But still, you can balance between the two in a more efficient way if you had a reliable simulator.
Professor Kato, your thought, please.
Yeah. So autonomous vehicles. I think we can, still apply existing technology for testing. Such as such as one defined by ISO. If it's for components. But what is difficult here is when you say safety of autonomous vehicles, it doesn't really mean only the safety of components. You also have to ensure the vehicle behaves in a safe manner, which is pretty hard to verify and validate. And from my understanding, nobody knows how to generalize the proof of this safety, the behavior. So simulation is one of potential approaches which can, test thousand cases of scenarios and use cases, which can reduce the corner cases of the risk of autonomous vehicles. But eventually, some risk still remains, which must be covered by insurance. So real-world test is more like a physical validation of the test. First you have to go through simulation. Then once simulator says yes, you're okay, now you can go for a real-world test. And finally, your government must define the level of acceptance for autonomous vehicles in both simulation and physical real-world testing. If you pass both criteria, then now you are ready to go. But this is very, very, ongoing work, and it's an open question for everybody.
I have a follow-up question for you, Professor Kato, on this. OEMs traditionally have been working in a very defined value chains with their tier 1 and tier 2s, doing R&D internally or working with suppliers, on their own development. And here you come with a totally new approach, right, which is open source, a platform that's open to the entire industry. And I know that you have a lot of customers and also a few dozens of sites out there in the world that where your technology is being tested. So can you tell us a little bit about that? How is it going to work?
Autonomous vehicles are, emerging technology. So in my opinion, if you build this technology alone by yourself, it's going to be very, very expensive. So since the market is not yet launched, so you may not be able to survive by the time the market is launched. So today, I believe what we're supposed to do is to split the expenses of technology. So we are providing open source software because we like to have everybody access this open source software so that they can skip some initial cost of development. Then they can build their, for example, proof of concept R&D on top of open source software so that they can reduce the cost of development. I think we should go through that way in early stage. Once the technology is getting mature, then yes, you can build the technology by your company. But today it is very expensive, so we need to find a way to split expenses of the development. That's what TFO wants to create.
Thank you, Frederic. Would you agree?
Yes, and we see the needs also to first to be able to collaborate quickly on a kind of more value network than on a traditional supplier, OEM, and several tiers, where people basically by themselves requires to have a collaboration environment, what we call collaboration hub, that they can create on the cloud for 1 week, for 2 months, 2 years, and invite a lot of partners to work together on either a subsystem of the car or a specific service of the cars and so on. And we really see that, and it's very dynamic. Value network can evolve very quickly. People can bring solution. It works. It doesn't work. They can see another code and so on. And I completely agree. On one side, we have large OEM that are investing a lot. They have capability, but it's not also sometimes not so creative, that having a lot of small company, small people, creative people, able to work together and to split the cost and the investment and also the innovation, on that capability. And we see that through our customer requirement to do that, by themselves on the cloud and on demand. Really, yes.
Right. Thank you. Professor Kato, do you have a question for the panel?
Yeah. So through this pandemic, I found trend change. Like before this pandemic, people believe that autonomous vehicles support human beings. Now, after this pandemic, now we more used to work from home, right? This means that even on a public road, but probably in most of private areas, it may not be human beings. It may be autonomous vehicles to work. Then human being, can support autonomous vehicles from, remote place. Could be home, could be office. This might be very interesting paradigm shift. And to make it happen, I think I'm very interested in teleoperation. So the reality of teleoperation. In order to make autonomous vehicles happen after this pandemic, I think teleoperation is one of the key technologies. So I want to see the state of the art of teleoperation today. What would be the most, significant problem to commercialize that technology.
I feel honored. I have to agree with you. We didn't foresee this pandemic, but we did foresee the need for teleoperation even before the pandemic. And I agree with you 100% that recently, even during this pandemic, we're getting more and more approached by various players that we never were in touch with before about the need to realize teleoperation in real environments.
Such as what?
Sorry?
Such as what?
Various needs from intra-logistics and logistics warehouses this was a hot market before, and now it's even hotter because it was less affected by the pandemic. All the logistics, it's still a very strong market. Automotive a bit less, but yes, the autonomous shuttle space, they're still going strong, especially in geofenced ODDs, operational design domains, like communities, and you have a 3-mile road here and a 5-mile road there. So various players that need teleoperation. So, Professor, to your question, if I understand correctly, what is so-called the number one gap between here and realizing teleoperation everywhere commercially available? It's quite simply the availability of the networks. Teleoperation relies on a connection. Now, we cannot bend the rules of physics. If the electrons are not moving in the antenna, then there would be no connection. If the signal does not reach the vehicle, there would be no connection. Now, we can work with very minimal conditions. We can work with 0.5 megabit per second of upload speed in data speed from the vehicle, and still you would see a viable video in real time, or almost real time, because it's not exactly real time, but very minimal delay, like we have. But there still needs to be connection. So in certain sites, certain locations, if you go inside a very long tunnel or very remote locations, like in agriculture, you would need to have some infrastructure, whether it's private LTE or Wi-Fi based. You would need to have a connection. Now, I will say that for most of our customer cases, this is not an issue because they do operate in urban areas and places where you have a connectivity, and it's only a matter of measuring the service levels. We commit to a certain service level, 99% point something, depending on the connectivity levels that we map and we measure, and we commit to that. So it's not like a real technology gap. It's more of a infrastructure gap in certain cases where you just have to have connectivity.
I have a couple of follow-up questions. Yes, connection capability is definitely one, probably the most significant. But second of all, I believe that, imagine that you work from home and you monitor probably 100 vehicles. So what about user interfaces? If it's one-to-one, if you ask to just monitor one vehicle, then yes, you just have your screen. But if you are asked to monitor 10 or 100 vehicles, then you may need some special user interfaces. And these interfaces and relevant facilities must also be certified because it's part of service. So today, we believe that certification needs to go to the vehicle components for sure. But if we apply teleoperation for thousands of vehicles, then I think you need to provide certification to these instruments that would be used for a teleoperation. What do you think?
If your system includes a teleoperation station and the connection to the wall and what kind of certified joysticks you would use, everything must be as part of certification of the system. And I agree, we have the interfaces, they need to be certified according to your local government. I agree 100%.
Thanks.
Okay, thanks. We're almost out of time. So one final and closing question. We're seeing newcomers doubling down investment on autonomous vehicles, such as Intel, for example. We all heard about the Dolev acquisition project, of course, Mobileye. And some other traditional players are deprioritizing. In kind of a one or two sentences around the table, Where is the industry going? Go ahead, Frederic.
Yeah, we see a diversification. You know, you are talking about insurance. Insurance are investing, but also we see connection with health, wellness of people, and capability to use this autonomous capability to also ensure better services to people, to go to the hospital, to bring kids to school, and also, as you said, you know, teleoperation will be very important to monitor and ensure security on that. So we'll see a lot of different industries that are converging on that, and maybe that something that was more automotive will become a topic for the city basically and for everybody. So we really see acceleration and more investment, but on with more stakeholders and more diversified people.
Dr. Kato?
I'm not sure if we should say they deprioritize, because we should say right this moment, because of this pandemic, yes, OEM and automotive manufacturers, they prioritize something different than autonomous vehicles this moment. To be honest, I feel that. But after this pandemic, because the value of autonomous vehicles still there, so eventually they prioritize production of autonomous vehicles again. In addition to that, if you look at different market, when you say autonomous vehicles, it doesn't only mean the robot taxis or owned cars. If you look at private areas such as factory automation, in-campus transportation, through this pandemic, I think there is more needs to have unmanned technology, which is backed up by autonomous vehicles technology. So on the public road services, yes, right this moment, it may be deprioritized because of this pandemic. But if you look at the different markets, such as private area, it is more prioritized. We really need, right this moment, unmanned operation services, which unfortunately we can't deliver it today. But all in all, the technology demand for autonomous vehicles actually more and more prioritized through this pandemic. That is my opinion.
Amit?
Yes, I mean, nobody has a crystal ball and nobody can predict the future, but just from what we are already seeing right now, my guess is that I mean, there is still money on the table, there are still investors, and those investors are looking to put their money into good companies. In general, I think you would see less companies receiving funding. So, I mean, overall, maybe the total amount of money in the world, I don't know how much it changes, but you would still have money going into fewer players. Less companies would get investments. Maybe relatively, they would receive more money to advance the self-driving robots and self-driving vans and cars and shuttles and trucks. And I think specifically in the automotive industry, you would see more and more consolidation. I think in 10 years from now, you would have less automotive companies, less OEMs, and specifically you would have very few companies that are really working on level 4 self-driving cars. I think you would see more and more partnerships like Hyundai and Aptiv, like Waymo and FCA. So you would have the self-driving software company like Waymo and Mobileye, for example, and you would have the OEM, which specializes in making the vehicle level 4 ready in terms of hardware and wiring and safety, because that's their expertise, and nobody can do it better than the OEMs. So you would see less OEMs, less self-driving companies, and more partnership between the OEMs and the self-driving companies.
Excellent. To me, this comes down to the basic need of saving lives. Sometimes we tend to forget that there are more casualties resulting from car accidents than coronavirus, for example, every year. And so even though the road is still long to mass adoption, and there are quite a few challenges to resolve, by the way, this is not a technology issue. I want to think that the humanity will eventually mass adopt this because this is something that's going to help us save ourselves. And with that, I would like to thank our panelists, Frederic, Amit, and Professor Kato. Thank you, EcoMotion. And thank you for our audience for listening in.